Hey, welcome everyone. In this section, we're doing things a little bit differently. I'm calling it Other Useful Things, a JavaScript assortment, hence the assorted bread on the right. As we've gone through this course so far, I've been trying hard to integrate new features, new JavaScript features as organically as possible, wherever they make sense. So we introduced string template literals really early on when we were talking about strings. We talked about let and const, which are new ways of creating variables. We talked about them right when we introduced variables. I introduced for of and for in, along with the regular for loops and while loops. Now, we can't do that for every single feature in JavaScript as much as I would like to, because some of them are more advanced or they require a whole bunch of previous knowledge in order for them to be useful. So that's what this section is here for. This section is going to cover this group of 3 new features in JavaScript. It's really more than 3. REST and spread are kind of separate things. But these are not necessarily related, except in the fact that they are new features in JavaScript. So I couldn't find an easy way to integrate them organically into another part of the course, so they get lumped into this assortment section. So we're going to talk about REST and spread, destructuring, and default function parameters. We also have some other new features we haven't covered yet, and those will get their own sections. So we're going to return to objects, then we'll talk more about classes, and then later on we'll also cover asynchronous JavaScript and async functions. So this section, as I mentioned, is really focused on REST and spread, default function parameters, and destructuring. So that's what we're here for. We're going to start with the second one, default function parameters. So the first of these new features we'll see has to do with adding default function parameter values. So we could do this in the past, we just now have a newer, more compact syntax to do it. Here's what I'm talking about. If we have a function, make sure I'm in the right window, we'll just go with our standard multiply, 2 parameters x and y, we return x times y. Right now, if we call it with 2 parameters, it works great. Actually, these are arguments. We're passing in 2 arguments. But if we leave one off, we get not a number. And that's because y is set to undefined when we don't specify a value. So if we wanted to have a default value for y, if a user or another function call or a developer does not pass in a second argument, we want a default value. We could, in the past, do it this way. We would manually check if type of y equals undefined. And if you don't remember how type of works, it does not return the actual value of undefined. It returns a string containing the type. So if I declare a variable w, the value of w is undefined. If I do type of w, I get the string undefined. So I see people do this sometimes, and this won't work because you're always going to get a string back from type of. So we need to make this a string. So if type of y is undefined, then we'll say y equals 1. And this is the older way of doing it. If we call multiply of 4, now we're multiplying 4 times 1, and we get 4. But if we pass in a value, for y, we get 12 in this case. So this is only happening if there is no y. There's a shorter way of doing this manual check before we get to the newer way, the newer feature. You could use a ternary operator where you set y equal to, and then we have our condition, type of y equals the string undefined, question mark. If this is true, we'll set y to be 1. Otherwise, y stays as y. So if you pass in a value like 5 for y, this is false. So this doesn't run. This is what we end up setting y equal to, y equals y. If you don't pass something in and it's undefined, this is true. So we end up setting y equal to 1. So this works, but it's still pretty clunky. It's not very user-friendly or developer-friendly. We have a much better way thanks to the new default parameter syntax. It looks like this right here. So we define our function, and right inside the parens, where we are listing the parameters, we can add a default with equal sign and then a default value. So here is the exact same thing except with a and b instead of x and y, where b will default to 1 if a value is not passed in. So I could rewrite this, if I comment it out, get rid of this entire line, y equals 1. And this just means if no y is passed in, if it's undefined, use this value. So I'll run my code again, make sure it still works, If we only pass in 8, we get 8. If we pass in 2 and 8, we get 16. Let's do one more example. If we were to define a function called greet, let's do it with an arrow function this time. So const greet equals a function, and this function will take a person and then a greeting. And the way I want greet to work is that I can call it like this: greet Tim, and then some greeting like yo, and it will print out yo Tim with an exclamation point, let's say. But if I just call greet Tim, it should default the greeting to hi, the string hi. So all we need to do is say greeting equals hi, and that will give it a default value if greeting is not passed. So let me move this over a tad. Let's add in our simple console.log. I'll do a template literal string, and then we'll add in the person, which is the first parameter, and then the second, actually, I guess we want to say greeting first, right? Yo Tim, hi Tim. So we'll do greeting with our curly braces, and then a comma, person, exclamation point. Let's try it. We'll do greet of Tim, and won't pass anything in, and we get hi Tim. But if we do greet of Tim and yo, we get yo Tim. Okay, so that's another example. We're using a string this time as the default value. You can also do things with arrays or objects if you wanted to. I'll just make up a dumb example. If we have a function called const blah, and let's say there are 2 parameters, and y will default to the array 1, 2, 3. Let's just console.log x and y. So this does absolutely nothing, but I just want to show you that we can use an array or an object or any other value in JavaScript as the default value. So let's call blah with 1, and we can see that x is 1, y is the array, but if I pass in 1 and 3, now x is 1 and y is 3. One really important note about default parameters is that the order absolutely matters. So if I add in a third parameter here, let's say for greet, I want a person, greeting, and then, I don't know, punctuation, which is this exclamation point at the end. If I want it to default to exclamation point, that's fine, I can do this. If I call greet right now, and I only pass in, oh, I need to update this so that I'm actually using the exclamation point or punctuation. If I call greet again, and I pass in Anya, we get hi Anya with an exclamation point. So both of those default parameters kicked in. Greeting is hi, punctuation is exclamation point. But it does not work, of course, if I tried to pass in person and punctuation like this. The way that they are interpreted, the way that JavaScript knows which one needs to have a default value is purely based off of the order you pass them in. So there's no way for me to say here, I want to pass in person as Anya and punctuation as question mark and use the default greeting. It doesn't work that way. So all the default parameters also need to come at the end of your parameter list. You can't make the first thing default and then have non-default parameters afterwards. So if we went back to multiply, this example, I couldn't do this. X equals 1 and then just regular y. If I try that and I multiply 2, what happens here? Well, x is going to be 2 and y is undefined. So there's no default for y. If I pass in 2 numbers, it works fine. But the default is never going to work the way I want it to work unless I'm fine with y being undefined as well. So this is not something you really see, and it's not something I recommend you do. Your default parameters come at the end. And that's pretty much it. So you can have as many as you want, although if you're finding yourself adding a ton of defaults to your parameter list, there's probably a better way of writing the function, but it's a really nice addition, just new syntax, compared to doing something like this, where you're manually checking for type. So that's it. That's the newer way of adding default parameters. The next new feature we'll take a look at is called spread. And the first thing you should know about spread is that, like every other feature we're seeing in this section, it's not supported in Internet Explorer. However, that shouldn't stop you from using it. So spread is extremely useful, but it's also not that easy to explain because it does many things, depending on the context. This is the official definition from MDN. I guess it's not official, but this is the MDN definition. Spread syntax allows an iterable such as an array to be expanded in places where 0 or more arguments for function calls or elements for array literals are expected, or an object expression to be expanded in places where 0 or more key value pairs for object literals are expected. You got it? Okay, so I think that's good enough, right? You understand at this point? Yeah, I know, very funny, Colt. There's a lot to spread. The key word that I bolded here is expanded. So in all scenarios, there's really 3 use cases: spread in a function call, spread in array literals, and spread in object literals. It all has to do with expanding some iterable into some other place, some destination. So the word spread is a nice choice, I think, because that's kind of what we're doing. We're spreading, we're expanding something. What I'm going to do is break it up into 3 videos, one for each of the use cases. And the first one we'll see is spread in a function call. So spread syntactically is always 3 dots. Here, when we're using it in a function call, here in an array literal, 3 dots, here in an object, 3 dots. Always 3 dots, but they mean something different, or they behave differently depending on where you use it. At the end of the day, it all has to do with expanding an iterable, meaning an array, a string. There are many other iterables, but those are the 2 main ones we've worked with. Expanding them into some other destination. And when we use it in a function call, inside the parentheses, it will take that iterable and break it up into individual arguments rather than passing in a single argument. So the example I used with was math.max, which accepts multiple arguments. Here's a bunch of arguments I just passed in, and it returns the max. So in this case, the maximum argument was 99. There's also math.min, which does the same thing, except the other way around. It tells me the smallest argument was 3. But this only works if you pass them in as separate arguments. If we have a list of numbers, or an array of numbers, it will not work. It treats it as one argument, and if I do math.max of nums, I get not a number. It expects each argument to be a number. This argument that we passed in is not a number. It's a list of numbers, but itself is not a number, so it does not work. Instead, we can use spread. So spread allows us to break this up into 5 separate arguments. It's the equivalent of passing in 45, 33, basically stripping away the array brackets. So this is what it looks like, ... nums. Just like that, we are spreading this iterable into individual arguments. So again, it's just like doing this: 45, 23, 34, 7, and 5. And we get 45. So to show you the other side of it, if you wanted to write a function, let's call ours give me 4. And this is going to be a useless function, but it wants 4 arguments, so A, B, C, and D. And then we'll just console.log each one of them. I'll do it like this: A, comma A, and then duplicate this a couple times, and then update this to be B, and then do the same thing for C and D. All right, so it's going to print out the arguments that we get. Give me 4, I'll pass in 4 numbers, 4, 5, 6, and 7. And we see A is 4, B is 5, C is 6, and D is 7. If I had an array of numbers, or an array of anything, let's go with const colors. We'll have red, orange, yellow, and green. If I call give me 4 and I pass in colors, we're only passing in 1 argument. So you see what we get. A is set to this whole array, B is undefined, C and D are also undefined. But if I instead use spread, 1, 2, 3 dots, we're now spreading that entire array into separate arguments. So now those array braces are essentially gone from the function call. We don't change the array in any way. Colors is exactly the same as it always was, but when we pass those values in, they now are 4 arguments. So A is red, B is orange, C is yellow, and D is green. And if we had more arguments, right now our function doesn't handle them. It only wants 4, but if we had colors that had 10 things in there, each one would be passed as an argument. We just wouldn't be using it in the function. but shortly in this section, we'll see how to write a function that accepts any number of arguments. Right now, we're having to hard code how many we want. This is 4. If I want 5 arguments, then I need to add in another parameter. But we'll see how we can add in n number and collect all arguments in a single array or a single structure. That's coming up soon. The other thing about spread is that it's not only applicable to arrays, so we could also do something like this. Let me make some space here. If I have a string, const, we'll just call it str, equals, how about goat, like that. If I spread a string is actually an iterable. What do you expect to happen here? If I call give me 4 ... str, it passes each character as its own argument. It iterates over this, and it's iterable. We've done it before. You iterate one character at a time, and you end up with one character, G, being the first argument, then the second, then the third, then the fourth. You can think of it as just like this. Each value or each character is passed as its own argument, and we would get the same result if we did it this way, give me 4. But the main difference is that this sucks to type, and this is hard-coded. If we use spread, this could be 20 characters, it could be 2 characters. It's not that common that you spread strings, at least in my experience, compared to arrays. But whatever you're spreading, when you spread it into a function call, that iterable is iterated over. Each element is passed as a standalone separate argument. So that's the first use case for spread. We have 2 more to go. Next up, we'll see the second use case for spread. If we go back to this paragraph of gibberish from NDN, spread syntax allows an iterable such as an array to be expanded in places where 0 or more elements for array literals are expected. So we can use those 3 dots inside of an array literal. We just saw how we can use it in a function call. In an array literal, it does something very similar. It takes an iterable and it spreads it out. It takes the individual pieces, and in the case of an array, it copies them over into a new destination array. So we can use it to combine arrays, to make a copy of an array. There's a whole bunch of situations where you may end up using spread. So let's check it out. I have a simple example over here. I have some arrays of really cool animals, some of my favorite animals out there. We've got cephalopods, which are basically squid, cuttlefish, nautiluses. So there's a couple examples in here. We've got gastropods, giant African snail, variable neon slug, a really cool animal, and cnidaria, which include things like jellyfish and corals and hydra and a couple other things. Anyway, we're going to combine them in a few different ways. Also, stick around at the end if you want to see some photos and videos of these. Some of them are pretty cool, but I won't waste your time in the middle of the video with that. So, quick biology lesson. Both of these right here, cephalopods and gastropods, they're both considered mollusks. So if I wanted to make an array with both of them called mollusks, or mollusca, I think is the correct Latin term, I could use spread like this, cephalopods, comma, ... gastropods. And this will make me a new array with both contents of those arrays combined into one. So let's take a look. What do we have over here? Mollusca has 6 elements. We had 3 from cephalopods and 3 from gastropods. Notice the order. I put cephalopods first, so we get those 3 elements first, and then gastropods afterwards. And the original arrays are untouched. We're just making a copy, or actually a new array with copies of both arrays inside. If I instead did it the other way around, and I did 3 dots with gastropods first, and then 3 dots spread with cephalopods, you can see the order is different now. So we have the first 3 from gastropods, the second 3 from cephalopods. The order does matter. Also, we could add in other elements if we wanted to that weren't present from these arrays. I could add in up front. What's another mollusk we could add? If I wanted to add at the beginning the garden slug, it would look like this. I just add it as an element, and then comma, and then spread, comma, spread more. And there we go. I could also combine more than one array. I could do all 3 of these arrays. They would be considered invertebrates. So const inverts equals, and then ... Let's do cnidaria first, ... gastropods, ... I need my comma. cephalopods. And if I look at inverts, we now have an array of 8 elements, all of them combined. Spread is great in situations where you need to combine arrays, but it's not doing something we couldn't do before. We have already seen how to use concat. So for example, cephalopods.concat gastropods. It gives us the same result that we had from this line, where we're taking the data from cephalopods and combining it with gastropods. And if we look at the originals, they're still unchanged. This is just a shorter syntax. It's easier to see and easier to reorder as you like. And we can add in elements wherever we want to. We can do multiple arrays combined. There's a lot we can do. And one of the most common use cases for spread is actually just to make a copy of an array. If I just want a second version of Cnidaria, actually, let's go with cephalopods. Cnidaria is annoying to spell. I could do const ceph copy equals array literal brackets ... cephalopods. And if I look at ceph copy, I now have the same data, and they have unique references, so they are not triple equals to each other. Ceph copy triple equals cephalopods is false. Versus if I had just made an array, like const, or I made a variable, const copy equals cephalopods, copy triple equals cephalopods will be true, as we've seen before, because they are referencing the same reference. They're pointing to the same reference. But when we use spread here, it is going to make a clone, a new array in memory with a new unique reference. But that does not extend to nested arrays, or if we had objects inside of the arrays, those won't be cloned. The references will remain the same, so it does not go multiple levels deep. So we can do this with arrays. We can also spread other types of data into an array. There's not many that you would do it with, but one example would be a string. If we wanted to get a string, like let's say we had A, B, C, D, E, F, G, imagine this is the whole alphabet, and I wanted an array where each character was one element. I could do .split, which we've seen already, and you pass in an empty string saying split this string on nothing, split on every character, and it gives us an array just like that. But I can also do this, A, B, C, D, E, F, G, and spread it. 1, 2, 3. And it's the same idea. What we had here with an array when we spread it, we're telling JavaScript to iterate over this iterable, and for each item in there, add it as an element in the array, which is what we did earlier with a different array rather than a string, but the same process. So we can spread strings, probably not that common that you would, spread a bunch of them into one array, but we could do A, B, C, comma, D, E, F, comma, hello, and then spread these guys, and that's what we end up with. A, B, C, D, E, F, and then hello at the end. So that's pretty much it for spreading into an array literal. Same idea as spreading into a function call. We're taking an iterable and breaking it into pieces and moving them or copying them to a destination. In this case, it's an array that we're creating. And as promised, I'll show you some of those animals if you want to check them out. Some of my favorite guys on Earth, favorite animals. We've got the Dumbo octopus, very adorable, tiny octopus, very cute. Giant African snail, horrifyingly huge snails. They're giant, as their name tells you, quite intimidating. Would not want to hold one of those in my hands. Then we've got a really cool animal called a variable neon slug. It's a species of nudibranch, these really cool flatworms that live in the ocean. Lots of them have beautiful, beautiful colors, as you can see here. And then finally, my favorite, the flamboyant cuttlefish. They're tiny, adorable little creatures with incredible skin and ability to display these patterns and change the shape of their body. Very hypnotic. Anyway, so those are some of my favorite animals. Thanks for joining me on Colt's Animal Hour. Back to JavaScript. That's coming up next. More spread. Wait, I forgot to show you the best part. Here we go. The way that they eat, this appendage comes out. Horrifying, and then snaps back. Okay, that's it for that. Next up, we have the third context we can use spread. It's down here at the bottom of the paragraph. an object expression to be expanded in places where 0 or more key value pairs are expected. So here's what it looks like. It's the same ... but we put it inside of curly braces, inside of an object literal, and it will copy over key value pairs, properties from other objects into a destination object. So effectively, we can make copies of objects, or we can create combinations of objects. We can put them together. So that's what we'll see in this video. I have two existing objects, one called feline, one called canine. They just have two stupid properties. They're family and the number of legs for cats, and furry set to true for canines. If I wanted to make a new object that included these properties, but also more properties, like a dog object will include everything from canine, and I'll also set is pet to true and adorable true. If we look at dog, if I run the code over here, we have those two properties from canine, the family and furry set to true. So those were copied over. We could also do the same thing for cat, const feline. Let's go with, how about house cat? That's fine. We'll spread feline, and then also add in is grumpy true, and personality unpredictable. At least my cats are. And if we look at house cat over here, we've got the properties coming from feline plus the properties we set right here. Now what can happen is sometimes you might have conflicting properties. Like if we added legs 4 to canine as well, they both have legs of 4. What happens when we merge them together? So let's do const cat dog equals and ... canine, comma ... feline. What do you think happens? Well, in this case, it's pretty simple because we know what happens in an object where we try and have two properties with the same key. They just overwrite each other. So we only have one legs property. But what if, let's say we have a 3-legged dog, const tripod equals, and I copy in canine, and then I set legs to 3. What do you think tripod looks like? Well, it does have legs set to 3, even though we had legs 4 in canine. The reason is that the order matters. So we copy the properties from canine first, and then afterwards legs is updated to 3. So if I switch them here and then ... canine, try it again, we look at tripod, now legs is set to 4. Legs was 3 originally, but then those properties were copied in and that overwrote it. So the order does matter if you have conflicting properties with the same key name. We can also use spread to create a clone of an object so that we don't have the exact same reference. We're creating a copy of the object, but just like with arrays, this is only one level deep. It will not clone nested objects or nested arrays. So if I wanted a copy of one of these existing objects, how about cat dog? I could do const cat dog clone equals ... cat dog. So cat dog itself exists or is created from two other objects. Two objects' properties have been copied over, and then I'm copying that cat dog object over into cat dog clone. Refresh my page, we have cat dog clone, and if we triple equals to cat dog, it's false. They are unique references because we made a copy. It's not the same reference. Another very important thing about spread in general, this is the only context where you can spread an object, when you're spreading into another object. If you tried to do it inside of an array, I'll do it over here. Let's see, how about canine or dog? This does not work. We get an error. Object is not iterable. So in the context of an array, it doesn't work. In the context of an object, though, we can spread objects. It does behave differently. And the same holds true if we were trying to pass this into, I don't know, math.max or something, which wouldn't even make sense, but we can't spread the object either. It's not an iterable. It only works if we're passing in an array that we're spreading, a string, or some other iterable, but an object literal is not one. Now, what do you think happens if I try the opposite? If I have an object literal and I try to spread an array into it, the array of 4, 5, 6, what happens here? No error. Instead, we get key value pairs based off of the indices. So 0 is the key, set to 4, 1 to 5, 2 to 6. Probably not that common that you would need to do that, but the same thing holds true with a string. We can spread a string into an object, but just kind of a weird thing to do. Never really seen it done. And the last thing I'll show you here is that we can create array literals that also contain object literals where we use spread in different contexts. So let's say I was making an array and I was spreading in the string hello for some reason. And then I also have an object as one of the possible values in the array. And in there, I spread in cat dog. So I'm combining them inside of an array. Let's create a variable here, const random equals. Get rid of that extra s. Random is an array with string characters first that we spread, and then an object that contains object properties that we spread. So we can nest them, we can create more data structures or nested structures where we spread, but the context matters. The way that spread works inside of this object is different than the way spread works right here, because here we're in an array, here we're in an object. Yes, technically it's nested in the array, but that doesn't matter. It behaves just the same as it did here or here. So that is spread. We saw 3 different situations where it works. We always use 3 dots. The first one we saw was passing into a function. Math.min was the example I used, where you can spread a bunch of values, let's say an array, into individual arguments. So they're passed as separate arguments. Then we saw how to use spread in an array literal, super useful, which helps us copy data from one array into a new array. We can combine arrays, essentially a nicer way of concatenating, or we can create a clone of an array. And then in this video, we saw how we can use spread in object literals to copy properties over from one object to a new object. We can create a clone of an object. We can create a hybrid where we take properties from 2 objects or 3 or 4 and combine them into one. We can add new properties in. Just remember that the order does matter if you have conflicting properties, like we did with the legs situation. So legs here, if we want legs to remain 3, should come after. All right, that's spread. A lovely, lovely new feature. Next up, we have another new operator or feature in JavaScript called REST. Now, I wrote that it looks like spread, but it's not, because we use the exact same 3-dot syntax, ... but REST behaves very differently. It's almost like the opposite of spread. What it does is, instead of spreading data out into arguments or into a new object or an array, it actually collects things down into a single array. So it's used when we want to make functions that accept an unlimited number of arguments or a variable number of arguments. For example, we've seen this method a couple times, math.max, where we can pass in as many arguments as we want, and it returns the maximum value. So how would we write this? How would we write code for a function, let's call it max, or let's do one called sum instead. Sum will return the sum of any number of numbers. So we could have 2 numbers passed in, so we could add 2 parameters, but what if we want to support 100 or 20 or 1? We would have to do something like this maybe, A, B, C, D, E, F, G, H, I, J, K, and even then we would eventually run out of letters and have to switch it up. And then how would it work? Because sometimes they would be undefined if you only passed in 3 arguments. So this is not the answer. There is a way of doing this without REST. It's called the arguments object. So in every function, we have access to something called arguments. It's a special name, arguments, and it kind of looks like an array, but it is not an array. It's 100% not an array. We don't have things like push and pop and all the common array methods you might want, but it is a list where we have indices, and we can loop over it with a for loop. So this has been around for a long time. This is not new. We're starting with the old way, and then we'll see the new way with REST. So using this is, as I wrote here, meh. It's not great. It's annoying, but I'm going to show it to you quickly. Inside of any function, we have arguments. So let's just console.log arguments. Notice that my function does not have any parameters listed. That doesn't matter. If I call it right now, sum of 1, 2, 3, arguments prints out, and we can see it has 3 values in it, 1, 2, and 3. If I call it with a whole bunch more arguments, 6, 7, 23, 45, 6, 6, 6, 6, arguments has 8 elements in it. So if I wanted to make sum actually work, I wanted to sum all elements, let's use reduce, which we saw earlier on. We'll get some practice again with it. We have arguments, and what I might want to try is arguments.reduce, and then remember our syntax here, we have the total, and then each current val. Let's go with cur val, and we'll return total plus cur val. And let's see what we get here. I'll also will return that. This will give us the sum, and then we return the sum. If I try it though, 1, 2, 3, 4, 5, oh no, arguments.reduce is not a function. Again, arguments is not actually an array. It's an array-like object. It looks like an array because we can access arguments of 0, or we can loop over it, but it does not have array methods. If I wanted to make this work using the arguments object, what I could do is turn it into an array. And one way of doing that we just saw is spread ... arguments. And then I could call this args array. And then iterate over that, args array. Now if I try it again, it works. We get 15, right? I think that's correct. Yes. So that's one of the shortcomings of the arguments object. Here's another situation where it's not ideal. If I wanted to define a function called, let's just go with full name. It accepts a first name, a last name, and then a bunch of titles, like optional titles someone could have, like, I don't know, order of the, I'm making these up, order of the Phoenix, or royal badass, or whatever titles there are. I know there's a bunch of them. Oh, junior, there we go. Or the third. And somebody could have, I think you would just do this, right? Is that how you do the third? Somebody could have multiple titles, but everyone needs to have a first and a last. And then what I'd like to do is just have everything else, any titles that were passed in, collected maybe in the arguments object, but there isn't actually a way of doing that. If I do first and last, in here if I console.log arguments, it just contains everything. So if I call full name of Tom Jones, and then pass in a couple other things like third and order of the Phoenix, if those are his titles. If we look at arguments, it just contains all 4 arguments. So we could still implement this function. We would just need to make sure to skip the first 2. If we're trying to get the titles that were passed in, Tom Jones, the third, order of the Phoenix, we would want these 2. We already have first and last. We still have access to those. I can print out first. I still have access to it. You can see Tom. It's just that arguments includes everything. So I just have to be mindful of that and know that the first 2 in arguments are already first and last. With REST, which we're about to see, that's not a problem. And there is one last issue with the arguments object. It does not work in arrow functions. If I define an arrow function, which I'll call multiply, if I try and console.log arguments, we'll call it multiply, pass in some numbers, it does not work. Arguments is not defined. So the arguments object is not a thing in arrow functions. So there's a couple shortcomings to sum this up. First, it's not a real array. So you have to turn it into an array if you want array methods. Next, there is no functionality provided for collecting remaining arguments. Like we saw here, arguments contains every argument passed in, even if we captured the first 2 in parameter names. And then lastly, the arguments object does not exist at all in arrow functions. So we've set the stage to see the new fancy syntax using REST. That's coming up next. Alright, so we just talked about the arguments object and some of its shortcomings. It's been around for a long time. It's doing the best it can. But now we have a new, nicer syntax in REST. So REST is 3 dots, 1, 2, 3, just like we use for spread, but we put it inside the parameter list of a function definition. And what it does is it collects all remaining arguments into a 100% real actual array, not an array-like object, not an array imitation, a real array. So earlier we wrote this function called sum using the arguments object. We had to convert it into an array. If we want to write the same function using REST, what we do is we put 3 dots right here, and then we decide on a name. And that will be the name of the array that contains all of the arguments. In our case, all arguments will be collected. So let's go with nums. And then we can start by just console.logging nums. We need to match that name that we gave it here. Let's call sum on 4, 5, 6, 7. And it's an actual array. It's not an array-like object, it's a real array. So I could implement the same functionality where I return using reduce on nums. So nums.reduce, and then we have our reducer function, which will be total, and then current val. I'll use an arrow function, and we just want to return total plus cur val. Let's check it out. It works. We get 22. So this is the simplest way to use REST. We're collecting all arguments, everything passed in, whether it's 20, the first one, the last one, they're all combined into the nums array. But we can also use it in a different way. We can use it to collect the remaining arguments, which is what I wrote here, collects all remaining arguments. So not just every argument no matter what. Instead, it collects the remaining arguments that have not been matched with a parameter. So if we go back to that example where I had full name, and I wanted a function where we have a first, a last, and then a list of titles, I could use REST right here to collect the remaining titles. First, last, those will be their own parameters. Then everything else is collected here. So I'll start by just console.logging first with first, and then I'll do the same thing for last, and then one more time for titles. And if I call full name, where I'm passing Tom as first, Jones as last, and then a bunch of arguments to be the titles, you can see what we get. First is still Tom, last is Jones, but titles only contains the remaining arguments. When we tried the same thing with the arguments object, it contained every argument, including first and last, or Tom Jones. But in this case, it is only collecting the unclaimed arguments, if that makes sense. So we have them collected in titles, and it's an array, and I could use titles to do something. I could iterate over each title, but I'm not going to bother with it. I just wanted to show you that we have a way of separating them out. We have first, last, and then everything else. Because of the way REST works, it collects everything. You wouldn't have multiple RESTs. JavaScript wouldn't know what to do, because the logic here is combine everything that has not been put in a parameter already into the titles array. So how could we have something afterwards if we just claimed everything before it into the titles array? You can name these whatever you'd like, as we've seen, and along with that, the order definitely matters. If you tried to do this, it's not going to work. Last would never have a value ever. And if you tried to do it this way, titles first, last, let's see what happens. REST parameter must be the last formal parameter. So JavaScript doesn't even let you try. It's telling you it has to be the last parameter. That's the only option. And then the last thing that is nice about it is that we can use it in an arrow function. So I could rewrite function sum, this function statement, the declaration. I could rewrite it as an arrow function. I'll just copy this and define it down here. Let's go with multiply actually. So const multiply equals our arrow function, and we'll call the parameter nums, the rest param that accepts everything into an array. And then let's do an implicit return. So we don't need to say return anymore. We'll do nums.reduce and then multiply instead of add. And we can use a double implicit return if we want to. Just do it on one line. Okay, so we have our arrow function here where we're using REST. We're calling the array nums. And because it's an array, we can call reduce. And then I'm just returning total times cur val in my reducer function. If you skipped over the reduce videos, I really recommend you check those out. I know they're a bit painful. Trust me, I had to teach it. It's not that exciting, but it is something that you'll use all the time. Anyway, let's make sure it works. So we'll call multiply. Multiply, how about 4, 5, 6, 7? And we get 840. Let's do something we can verify easier. 2, 3, and 4 gives us 24. Great. So we can use it in arrow functions, which we could not do with the arguments object. We can use it as an array because it is an array, unlike the arguments object where we had to convert it to an array. And lastly, we have more discretion over what it collects. We can tell it to only collect the remaining arguments after certain specific parameters, hence the term rest, versus the arguments object just contains everything, every argument no matter what. So when I say that rest is kind of like the opposite of spread, maybe you can see what I mean. We are collecting elements or collecting arguments into an array. We're not copying them over. We're not spreading. If we do something like this, where we are using spread, we're taking a single element and breaking it up into multiple pieces into an array. We're copying it over one element at a time. Versus when we use rest, we're doing the opposite. We're taking multiple disparate elements, arguments, and combining them into an array. So the syntax is the same, but that's why we have a different name, rest versus spread. I guess there's a world where it could have just been spread, but it's called rest. It has its own page on the docs because it behaves differently, and it's sort of the opposite. So that's it for rest. We have a couple more new features in JavaScript. One of my favorites is coming up called destructuring. The next new feature we'll see is called destructuring. Now, destructuring is a really nice, clean way to unpack values from data structures, from arrays or from objects, into their own separate, distinct variables. I really liked this clip art that I found showing this man unpacking, taking a piece, one box out of this cluttered mess. It's kind of, I guess, a visual metaphor. I also liked this one. I couldn't decide which one was better. Here, we're doing the same thing. We have a collection in that van, and then we are removing one piece or a couple pieces individually. We're selecting them and, I don't know, creating variables with them. That's what you're supposed to think based off of this image. Destructuring is kind of like spread in that we can use it in different ways. So I'm going to break it into a few short videos. And the first one we'll see, the first option when we destructure, is to destructure arrays. When we destructure an array, we can unpack specific values out of that array into new variables. So here I have an array of marathon results from the men's 2016 marathon at the Olympics, and they're in order. So the gold medal went to Eliud Kipchoge, all the way down. I think I go to 6th place here for Jared Ward. If I wanted to create variables for, let's say, the first 3, and I wanted to make a variable called gold and make it set to Eliud Kipchoge, I could do it this way. Const gold equals race results of 0, and then duplicate that and do silver here equals race results of 1, and bronze equals race results of 2. And that works, of course. That's sort of standard array stuff we've seen before. Pre-destructuring, this was the only option. This was how you created variables based off of an array. You referenced a specific index and you saved it to a new variable. But now we have a much cleaner, shorter syntax where we can unpack the values all at once in a single line. Here's what it would look like. Equivalent to this, we would write const array brackets, and then we write our variable names in here. Gold, silver, and bronze equals race results. So what this will do right here is go into race results and use the order that we wrote them in right here. These new variables will be created in this order based off of their position. So gold will be set to the first item in race results, which is Eliud Kipchoge. Silver will be set to, I'm sorry if I'm butchering these names, Feisa Lalisa, and bronze will be set to Galen Rupp, and we'll have 3 new variables. So we won't have new variables for these, the final 3 results or the final 3 elements, but the first 3 will each be assigned to a new variable. So I commented out the original version, but if I look in my console, I still have gold, I have silver, and I have bronze. The race results array is unchanged. I'm simply making a variable referencing the value at each index. Just like we had before here, this doesn't change race results in any way. We're just accessing and making new variables. Same thing here. So the position matters. If I were to swap them and do silver and then gold, I would end up with silver as Eliud Kipchoge. That's the first index in our destructuring statement. So we get that first index in the array. And gold would be set to Feisa Lalisa. So this is the basics of destructuring. We could do a variable for each element, but there are some other things that we can do as well. If we wanted to skip an index, let's say I want the first and the fourth results, and I want a variable called first, I could do that, race results. That one's easy enough because we know first is going to be the first element. If we take a look at first, we have Eliud Kipchoge again. But if I want fourth, if I just write fourth here, we're going to end up with Feisa Lalisa as the fourth variable. But if I add extra commas, so the first extra comma is going to skip one index and go to Galen Rupp. If I take a look now, fourth is set to Galen Rupp, which is actually the third element. So I could add another comma to get the fourth element. And now fourth is set to Jerme Gebrselassie. Okay. And another thing we can do is actually use the rest ... inside of our destructuring between the array braces in order to collect the rest of an array into a new variable. I could make a variable called winner to get Eliud Kipchoge, and then everything else, all the other 5 strings in this array, could be collected into a new variable. It would look like this: const winner, comma, and then ... Let's go with others. It's not the best name. It's kind of minimizing their accomplishments. The winner and then the others. Meanwhile, all these people ran like 2-hour, 10-minute marathons or faster. But let's just go with others. Race results. And we'll have winner set to Eliud Kipchoge, and others is an array of 5 elements, the other 5 in that array. And I could combine these. So if I wanted to skip, for some reason, Feisa Lalisa, now others is going to contain 4 elements. And we didn't capture Feisa Lalisa in a variable at all. So I'll undo that. That's pretty much it for destructuring arrays. You just come up with variable names. You assign them in one line, like I have here. I mean, you could break it up if it's a super long line, but most of the time it fits in one line. You set it equal to whatever array you're trying to unpack, and then you single out the elements you want based off of the position. You can use commas to skip elements, and you can use ... the rest operator, to collect the remaining or the rest of the array into a variable. Next up, we'll see that we can use destructuring to unpack values from an object into standalone variables, just like we could for an array. But the main difference is that in an array, we would unpack based off of position, the index, so the first variable would be the first element, second would be the second, and so on. In an object, we make the variables based off of the name of the property. So here's an example. I have an object called runner. I'm still going with the marathon theme. We've got first is Eliud, last name is Kipchoge, country is Kenya, and title. This is pretty crazy. I was checking out his Wikipedia page, and he had this after his name. Elder of the Order of the Golden Heart of Kenya. That's a pretty awesome title. Elder of the Order of the Golden Heart of Kenya. It's a little long, but pretty cool. If I wanted to create variables for, let's say, first and last, all I need to do is follow the same pattern, where instead of an array bracket, I use object curly braces, and I'll set it equal to runner, and then I single out the properties that I want. The order doesn't matter at all. It's just the name that matters. First and last, let's run the code, and we'll see that first is set to Eliud, and last is set to Kipchoge. So if it finds this property based off of that name, it will take the value and store it in a variable with the same name. So first and last were both found, and runner is unchanged. It's still the same object. We could also try something like, how about time, which is not in this object. What do you think time will be set to? Undefined. So no error. We just made a new variable called time. It still made the variable. It's just set to undefined. With what we've seen so far, the variable names must be existing key names in the object, but we can give them new names if we wanted to. I'll do something similar. Let's try const, and let's grab the country but instead save it to a variable called nation. To do that, it looks like this: country colon nation equals runner. So this will make a variable called nation based off of the value found in country. If we take a look at nation now, if I run my code over here, it's set to Kenya. So I could try one more. Let's also do title. What would be another name we might want to use instead of title? I think this is also called an honorific, so we'll go with that, title, but we want to make a variable named called honorific. Okay, so find title in this object if you do find it, and then make a variable with that value called honorific. Let's run it. We've got honorific over here. Yep, we do. So title is not a variable, neither is country. We just use those keys to access data from runner in a super nice short syntax. The one other thing that I'll show you here, with objects at least, is that we can use the REST operator just like we did with arrays. I could single out country or first or last and then collect everything else in a new variable. So I'll just do const first, last, and then dot 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 others again, or just other equals runner. I'll save, refresh the page. So we still have first, we have last, but now I have a variable called other, which contains the other two properties we didn't claim. We didn't unpack them into their own variable, so we put them in the other variable, thanks to REST. If I left the dot 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 off, it's a totally different meaning. It's trying to find a value, or a key rather, in runner called other, but that doesn't exist. All right, so that's the basics of object destructuring. Similar to arrays, similar concept, but rather than using position, we're using the property name to destructure, to unpack. Next up, sticking with destructuring, I'd like to show you how we can work with nested objects and arrays and combine what we've seen so far to extract individual values into variables, to unpack them. So I have an array of objects, still going with the marathon theme. So each object is a marathon runner, and they are ordered still by finishing position. So we have gold, silver, and bronze from the 2016 Olympic marathon, the men's marathon. If I wanted to extract, let's say, the country of second place, right here, Ethiopia. Using destructuring, I'm inside of an array. So I'm going to start with the array braces. I'm going to set the whole thing equal to results. And in this array, I want the second element. So I'm going to skip the first one, and then I'm now in the second element, or I'm in that position, and we have an object. So inside of that object, I want country. It's kind of annoying that my editor is putting it on multiple lines, so I'll leave it like this so you can see it here. If I run it right now, let's see what we get in country. We get Ethiopia. So this comma is crucial. We're skipping that first element. If I wanted to extract something from that first object, let's say I wanted to get first name, which is Elliot. So I'll write first, and if I want to give it a different name or a different variable name, let's go with gold winner. I'll refresh, and I'll look at gold winner. It's set to Elliot, and our country variable is still set to Ethiopia. So the point here is just to show you that we can combine the syntax. It can get a little crazy, and I don't recommend nesting and doing a whole bunch of destructuring with nested structures. Instead, if you have like super nested stuff, I think it's a lot easier to understand what's going on. So rather than getting country this way, maybe it would be easier to understand if we did const, skip the first element, and then go with silver medal equals results. And then from inside of silver medal, we could extract country. So it's an extra line, but some might say it's easier to read. This isn't bad, but if you had more nesting that you were trying to work with and continue to destructure from, let's say inside of country, we had an array. Maybe someone is from multiple countries or they've competed for multiple countries before, and we wanted to extract something or unpack a value from there, then we would have another array, and it just gets complicated to destructure from. So just keep that in mind. You can nest it. That's it. I'm done. There's one more place you'll often see destructuring used, which is inside of a function definition where the parameters are listed. We can use this syntax, the same destructuring syntax we've seen, to destructure an array or an object, but if we put it inside the parentheses of a function definition, what this will do is extract or unpack values from the arguments passed in. So what I'm doing here is saying I'm expecting full name to be passed an object, hence the curly braces, and I only really care about first and last. So the object could contain a whole bunch of other things, but I'm only going to extract first and last and use them. So let's try it out. We'll define a function. We can use an arrow function, a regular function expression, a function declaration, it doesn't matter. Let's go with function print. How about just print? And rather than just accepting a person like this, and then extracting the parts we want from person, if we're going to print out something along the lines of, let's go with first, last, and then title. So if we pass this runner in, we would get Eliud Kipchoge, comma, Elder of the Order of the Golden Heart of Kenya. So we could destructure first, last, and title from person, const first, last, title, whoops, title equals person, and then console.log here. And I'll use a string template literal to display first, and then a space, and then last, comma, and then title. And this should work if I run print runner. There we go, Eliud Kipchoge, comma, Elder of the Order of the Golden Heart of Kenya. But if I wanted to instead destructure the object right here, I can shorten my code up significantly. So I'm going to duplicate this and comment out the original and get rid of this line entirely. And instead destructure right here. So when the data is passed in, we'll just grab the parts we want. We'll unpack first, last, and title. We don't need the rest of the object. Here we have person, so we could access country if we needed to, or let's say there was 50 other properties. We would have access to them in here, but if all we need is these three, then why not destructure them? Just make it cleaner. Now, if I run this code, it still should work. Print runner, we get the exact same output. So that's pretty much that, at least for objects. We can do the same thing with arrays, and I'll do a slightly different example. Here I have an array that could represent a HTTP response. If you're not super familiar with HTTP, don't worry. Some frameworks and some technologies will represent a response from a website as an array, and each line of the response will be represented as one element. And if I wanted to write a function that used the status code, which is the second element, what I could do is define my function. Let's go with parse response or something. And let's destructure this element out of response. So this is an array. If I'm expecting an array to be passed in, I could grab each individual piece right here. So this first element, let's call that protocol. The second element would be status code, and the third element would be content type. Now inside of here, I have access to those pieces, and let's just print status code. Let's do status colon status code. And if I run parse response, parse response, and I pass in my response, let me open this up a bit, we get 200 OK. So we're destructuring in the exact same way. When a value is passed in, this is expecting an array to be passed in, and we are unpacking all three elements, or the first three. If there were more, we would be ignoring them. Versus up here, we're doing the same thing, but with an object, and we're unpacking based off of the property name. So you'll see this often, far more often with objects, definitely, where you just need one or two pieces of the object, or maybe more than that's fine, but you don't need every single thing. And it's just a nice way to shorten your functions up, make things cleaner, and not have to declare variables in the function. You can just grab them in the definition when an argument is passed in. And that's pretty much it for destructuring, a really versatile new feature. You'll see it a lot in the real world as well. And I'm going to be quiet.